Engine oil and filter change. Objectives: renew the engine oil and oil filter. Warning: new and used engine oil can be hazardous. Be sure to read warning in general precaution in section. Before draining engine oil, check engine for oil leakage. If any evidence of leakage is found, make sure to correct defective part before proceeding to the following work. Drain engine oil by removing drain plug. After draining oil, reinstall drain plug and tighten it securely. Tightening torque. Loosen oil filter by using oil filter wrench. Apply engine oil to new oil filter O-ring. Screw new filter on oil filter stand by hand until filter O-ring contacts mounting surface. Caution: to tighten oil filter properly, it is important to accurately identify the position at which filter O-ring first contacts mounting surface. Tighten filter 3/4 turn from the point of contact with mounting surface using an oil filter wrench. Replenish oil until the oil level is brought to full level mark on dipstick, oil pan and oil filter capacity. Start engine and run it for 3 minutes. Stop it and wait for another 5 minutes before checking oil level. Add oil as necessary to bring oil level to full level mark on dipstick. Fuel supply layouts both in petrol and diesel engines. Objectives: identify different components of fuel supply system. Understand the difference between the mechanical and electrical fuel supply system. Inspect and identify the difference between the petrol and diesel fuel system. Carburetor. In the gasoline engine, the carburetor or the ECM is used for mixing the air and the fuel. Most 4-cylinder engines use the ECM system. Only some small engines use carburetor. The carburetor uses same principle for mixing the gasoline and the air, that is, a fuel spraying hole is made at the venturi and the airflow at the venturi is high. Hence the pressure at the fuel spraying hole is decreased. The gasoline will be followed by the airflow in the fog form and is mixed with air. This phenomenon is called venturi effect, named after the inventor. The carburetor has a simple structure and therefore is very economical and has fewer defects. As the modern engines need to enhance the emission, the fuel efficiency and the power output, the conventional carburetor poses many shortfalls. Mechanical fuel injecting device. A carburetor fails to supply proper amount of gasoline as it uses only mechanical device. Hence, it cannot maintain the air-fuel ratio uniformly. To prevent wastage of fuel and to enhance the engine response, it is necessary to control the injected fuel amount exactly using the predetermined air-fuel ratio. The K-Jetronic, invented by Bosch, is a new system developed in which the inhaled air amount is measured directly and the gasoline is sprayed to the intake manifold with the optimized air-fuel ratio using the mechanical device. Electrical fuel injection system. The main part of the electrical fuel injection system is the fuel injecting device deciding the amount of fuel to make proper mixing ratio by measuring the inlet air amount. This system comprises the device for measuring the volume of air, the device for injecting the fuel, and the device for controlling these operations. With these devices, it's possible to control the air-fuel ratio precisely. A controller decides the gasoline amount optimized to the driving status and the running condition of the vehicle. This is called as the ECM, Electronic Control Module. By memorizing the data concerning to some combinations of these signals and control method, the computer installed in the ECM indicates the amount of gasoline to be injected based on the operation of the accelerator. The carburetor uses mechanical pump. ECM system uses electrical pump. A regulator and a pressure controller supply the gasoline to the injector after controlling gasoline pressure within the specific range. An injector is used for injecting the gasoline. The injector has a needle valve closing the front of the nozzle so that the valve is opened by passing an electric current to the solenoid to inject gasoline, corresponding with each cylinder. The MPI according to the injecting timing can be classified into point injection, group injection, bank injection. Layout of diesel fuel system. Most engines use a jerk pump which builds up the pressure at the instant that injection is required. The two common types of injection pumps used are inline, a series of separate pumping elements arranged side by side; distributor (DPA), two opposed plungers supply the fuel under pressure to a rotor, which distributes the fuel to the appropriate cylinder.